In this video, we're going to go over vocabulary for transversals. So transversals, day 1. Two lines that do not intersect and are coplanar are called parallel lines. Two lines that intersect to form a right angle are perpendicular. Just a little review. A line that intersects two or more coplanar lines is called a transversal. And this is our new vocab word. This is what we're going over today. So parallel lines, I'm going to draw an example. They never intersect. Perpendicular mean they create a 90-degree angle when they intersect. And the line that is a transversal intersects two or more coplanar lines. So if I had like two parallel lines, the transversal would be the line that cuts through it, because it touches two lines. This line right here would not be a transversal because it only touches it, has one intersection on it. Alright, alternate interior angles. Alternate means that they are on, let's just say that they're switched. Or you could say opposite. Interior means that they are inside. And I'm going to give you a few examples. So if I had two parallel lines in my transversal, it would mean that I would have angles, those two angles. So they are inside the parallel line, so inside, interior, and then because they are on opposite sides, they are called alternating. So another example of this would be if I had this angle right here on the right side, on the in, then I would also have to have the left. They would be interior, alternating. This is how you would solve them. So you would solve these by setting them equal. So same size angle, set equal. Alright, let's try the alternate exterior. So alternate still means switch or opposite, but this time exterior means they will be outside. So I'm going to draw these again, my transversal. If I have this angle outside on the right, then the alternating exterior will be outside on the left. So they are outside the parallel lines and they are alternating. Our other case where they are exterior altering, if I had the top right, I'd have to have the bottom, top left, I'd have to have the bottom right. And to solve these, they're both the bigger angles, they're the same size. So when angles are the same size, we set them equal. Corresponding angles. These ones mean that the angles are in the same place. So like if I had the top right corner highlighted, then the top right on the other intersection would also be highlighted. Another way I like to think about this one is if I were to take a string on that intersection and pick it up off of the transversal and slide it down and drop it on top of the other intersection, it would highlight the same spot. So let's give you one more example of this one. Transversal, if I have the, let's say, bottom left on this intersection, then on this intersection I would also have to have the bottom left. These are also the same size angle. So we would set them equal. Consecutive means that they are on the same side. Interior means inside again. So if I have my transversal let's say I have inside angles on the same side. This is what it would look like. They're interior angles on the same side. The other example is if I had this angle on the right side in, I'd also have to have the other one. Those are interior, same side. So to solve these, they are different sizes. So when they are different sizes, it helps to think these two together make a line. So I need to add up to equal 180 degrees. So when we have consecutive exterior, so same side, outside, that means that this angle would match with this one. So they are exterior, same side of the transversal. Another example for that one would be if I chose the left, I would also have to have the left outside. So they are outside the parallel lines and they are consecutive. These angles, this one's big and this one's a little bit smaller, so different sizes mean that I add up to equal 180 degrees. And just to review vocab really quick, let's go over some that we've learned from prior lessons. So here's a little review. If I have angles that are across from each other, these are called vertical angles. They would be equal. They're the same size, they'd be equal to each other. If I had a line and I had these two angles, that would be called linear or supplementary, which would mean they would add up to 180. And then the last one is if I had a right angle, they would be complementary and equal 90 degrees. All right, let's try a few examples of how we will use this vocabulary. On problem 3, I'm going to name what type of angles they are. I highlight. Now, sometimes we can just go through vocab and see what works. So are both of these angles inside the parallel lines? This one is the only one inside, so it's not interior. This one is outside, which means they're not exterior because they're not both outside. Now let's check. Corresponding means that if I pick it up, move it, and drop it, they're in the same location. Top left, corresponding. Which means these two angles are the same size, so to finish, I'm just going to label it 55 because they're the same degrees. On 4, highlight. Notice that both of them are inside the parallel lines. That would be interior. And then I check, are they alternating or same side? They are going to be alternate because they are alternating. Which means they are the same size of angle, so it's 81 degrees. Five, they are interior. They are same side, so consecutive, which means these should add up to 180. So question mark, or x plus 85 should equal 180. To get x by itself, I minus 85. We get x equals 95 degrees. So that angle right there is 95 degrees. Problem 6, they are both interior, same side, so that word is consecutive. When they are consecutive on that line together, I set them equal to 180. I'm making sure to show my work when I have to equal them to 80. So this angle is 78 degrees. All right, I'm going to go a little bit faster through these. So we have vertical angles. Vertical angles are equal, so I can just put 51 degrees. Corresponding, because they're in the same spot, top right, which means they're the same size. When they're straight across from each other, they are called vertical. They are also the same size, so 112 degrees. Top left, that's called corresponding. So they are equal. Bottom left, corresponding. So this has to be 130 degrees. Ooh, these ones are on the same line. That means they are linear, or you could also say supplementary. Linear is more specific, but supplementary works. X plus 121 should equal 180 because a line is 180 degrees. X is equal to 59 degrees. All right, now we're going to go to 13, sorry. On 13, top left, corresponding. Man, there are a lot of corresponding, same size angle. Bottom left, corresponding again, which means they're equal. Ooh, these ones are inside parallel, so interior, and then they're alternating, which means they are equal, same size. This time they're both outside of the parallel lines, which means they're exterior, and they're alternating, which means this has to be the same size as well. Same size angle. 17, I have that they are interior on the same side, consecutive, which means they should add up to equal 180. So that angle is 130 degrees. Bottom left, corresponding, which means they're the same size, so this angle will be 124. Make sure on your homework that you show your work whenever they should equal 180 degrees. And that is how we label transversals and solve for missing angles.